Good morning, one and all. I am Dr. Lalitha, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. In this video, we are going to learn about voltage division and current division rules. So, what is the necessity of voltage division and current division rules? What is the purpose of using voltage division and current division rules? All those we are going to discuss in this video. So initially, any electrical circuit is classified into two types. They are series circuits and parallel circuits. Means resistors, based upon the connection of resistors, whether the resistors are connected in series or parallel, it is divided into series circuit and parallel circuit, or combination of series and parallel circuits. So according to this video, we will discuss about the series and parallel circuits only here. The combination of series and parallel circuits were not discussed in this video. So series circuit and parallel circuit. So these are the main components of any circuit. So a series circuit is one in which the resistors are connected in series. Means let us suppose this is one resistor and this is one resistor. So resistor R1 and resistor R2. Okay, the total current I which is flowing through the circuit will be same throughout the circuit. Means the current which is flowing through R1, the current which is flowing through R2, throughout the circuit the current will be same in the series circuit. So this is a series circuit. But in the parallel circuit, what will happen? Current division will take place. If you see here, this is a parallel circuit, R1, R2. So if you see here like this, if the current I is passing like this, what is happening here? It is having the two paths to go. Some of the current will go like this and some of the current will go like this. So the total current I is splitting into two parts. Let us suppose that is this is I1 and this is I2, because the current flowing through resistor R2 is I2 and the current flowing through resistor R1 is I1. Let us suppose like that. So in the parallel, I is equals to what will happen? The total sum of currents, means I1 plus I2. So the current division will take place in the parallel circuits, but in the case of the series circuits, the current will be same throughout the circuits. So that is the difference in between the series and the parallel circuits. So these series and parallel circuits will act as a voltage divider and current divider circuits. So now let us see how it will convert it into voltage divider, or how it can be used into voltage divider and current divider circuits. So this is a basic circuit diagram. If we see here we had connected the voltage source and there are two resistors which are connected in series. So the property of the resistor is to oppose the flow of electrons through it. So in this opposition, there will be some loss in the voltage in the form of voltage drop. So for every R1, there will be some voltage drop like this. So let us consider this voltage drop is V1. So similarly, according to the previous theory, so R2, for R2, V2 also will be some amount of voltage drop will be there. Means irrespective of the supply voltage, we'll have some voltages here also across each resistor, and that drops we had named it as V1, because the resistor we had named it as R1, so I had named it as V1. So here the resistor is R2, so I had named it as V2. So drop will be there definitely across each resistor, but the drop may or may not be equal across the each resistor, because every device or every equipment, see, this resistor is one separate element, this resistor is one separate element. So across every element there will be some amount of voltage drop, but that voltage drop means, for example, here across R1 V1 is there, across R2 V2 is there, but these two voltages may or may not be equal. We can't say that these two are same value of resistors. For example, this is 2 ohms, this is 3 ohms, sorry, this is also 2 ohms. So these two are same resistors, so the voltage drops across each resistors also will be same. We can't judge like that. Even if it is 2 and 3 ohms also, maybe this V1 and V2 will be same. So we can't judge according to the values of resistors. So there will be some amount of voltage drop always exist across the resistors that may or may not be equal. So here V1 and V2 are the voltage drops across the resistances R1 and R2. Okay, but the total current will be same throughout the circuit, because whenever the resistors are connected in series, voltage varies, but the current will be same throughout the circuit. So if I had given a V voltage, so according to this V, the value of current will flow into the circuit. This current will be same throughout the circuit, irrespective of voltages. Now let us see the derivation of the voltage division rule. So this is the same circuit which I had told you before. Now let us see the derivation. So according to the Ohm's law, what we know? We know that V is equals to I into R. So from this basic principle only, we are going to derive the derivation of voltage division rule and current division rule. So V is equals to IR, but here I am having two resistors R1 and R2. So here R1, here R2. So that's why across R1 there will be V1, across R2 there will be V2. But these two values will be, here also the Ohm's law will be applicable, here also the Ohm's law will be applicable. So that's why here I had written two times. So V1 is equals to I into R1. That means for this element or this voltage drop, according to the property of the resistor, V1 will be the voltage drop across resistor R1. So for V1 we are writing the equation here, for V2 we are writing the equation here. So V1 is equals to I into R1 and V2 is equals to I into R2. So the total resistance of the circuit. Now we have to determine the total resistance of the circuit. So what is the total resistance of the circuit? So here two resistors are connected in series. So if two resistors are connected in series, what is the equation? R is equals to R1 plus R2. The same equation I had written here. So R is equals to R1 plus R2. So from this basic equation, we know that V is equals to I into R. So substitute this R1 and R2 in terms of or in the place of R. So I is equals to, in this R we had written as R1 plus R2. So R1 plus R2, this is equation 2. Keep it aside. But we know that here we are having I value. I into R1 plus R2. This I value we know. What is the I value? I is equals to V by R. I is equals to V by R. According to this principle only. From here we will get I is equals to V by R. But here I is equals to V1 by R1, that is equals to V2 by R2 because the current in the series circuit is same. So let us consider this as equation 3. So substitute this I value here. So then what we will get? V is equals to V1 by R1 into R1 plus R2. So now I want V1, right? For V1 we are going to find out the voltage drop. So V1 is equals to, I am writing V1, I am keeping it here. So V into, I am keeping it this side, I am changing the R1 to here. So this is in multiplication mode. So it will become, it will be in division mode, it will become multiplication mode. So V into R1 divided by R1 plus R2. So V1 is equals to V R1 divided by R1 plus R2. So this is equation 4. Similarly, if we write the equation for the second voltage drop also, we get V is equals to V2 by R2 into R1 plus R2. Or finally, we will get V2 is equals to V into R2 by R1 plus R2. So these two are the equations. So how many number of voltage drops are there? We can find out the total number of voltage drops in the similar procedure. So for better remembering of these formulas, remember the formula in such a way that in order to find out the voltage drop across any particular resistance. Okay, for example, I am going to find out the voltage drop V2. So we can easily remember this formula as, okay, voltage drop across particular resistor is equals to total voltage V into across which value of resistor you are going to find out the voltage drop. V2, I am finding it near to R2. So into R2 divided by total value of resistance in the circuit. So this is a series circuit. So the total value of resistance is R1 plus R2. So V2 is equals to total value of voltage V into, okay, across which value of resistor you are going to find out the voltage drop, R2. So R2 by R1 plus R2. So similarly, this is the formula. Similarly, if you want to find out the voltage drop across R1, so V1 is equals to total value of voltage into V1 can be found near R1. So R1 by R1 plus R2. So V1 is equals to V into R1 by R1 plus R2. Means the total, wherever you are going to find out the voltage drop in the circuit, then the value of the voltage division rule is total value of voltage in the circuit into across what resistor you are going to find out the voltage. So that resistor value divided by total resistance value of the circuit. So these are the formulas for the voltage division rule. Now let us see about the current division rule. So this is the current division rule. So see here, current division rule. So current means this is the flow of current here. So current division rule will be applicable for the parallel circuits. So here the total current I is splitted into I1 and I2. So here two resistors are connected in parallel. So here the total current is splitting into two parts. Near to the R1, I1 is coming, near to the R2, I2 is coming. So now let us see about the current division rule. So here the figure shows the current divider circuit where the total current I is divided into I1 and I2 across the two branches R1 and R2. So now let us see the derivation here. So there we had taken V is equals to IR from the Ohm's law because we are going to find out the voltage there in the voltage division rule. But here we are going to find out the current value. So that's why here I am writing I is equals to V by R. With respect to current, there we had used the voltage. So with respect to voltage we had written. Here we are writing with respect to current. So with the current we are writing down here. So I1 will be there, I2 will be there, right? So I is equals to V by R. So V by R1. I2 is equals to V by R2. So why I had written VE and V? Actually it is V1 and V2, no? But I had written V and V. Why? Because in parallel circuits the voltage will be same. But in the series circuits the current will be same in the circuit. So this is a basic principle which I told you in my first video. So that's why I had applied like this. So I1 is equals to, means what will happen here? V1 is equals to V2 equal to V. So that's why I had written I1 is equals to V by R1 and I2 is equals to V by R2. So equivalent value of resistance. So what is the equivalent value of resistance whenever the resistances are connected in parallel? In series means we had written R is equals to R1 plus R2. But in parallel the formula is R is equals to, or R equivalent is equals to R1 R2 by R1 plus R2. So now let us take it as equation 1. So from this circuit, so I is equals to V by R. So V into, see here it is 1 by R, right? Into, so this value got reversed. This is R value, but here by R is there. So denominator went to numerator here. So R1 plus R2 by R1 R2. Okay. So now the voltage across both the resistances are same. We know that. Okay. So now V is equals to IR. IR means I1 R1, that is equals to I2 R2. Why? Because in parallel circuits the voltages will be same. So from these two equations finally we will get that I is equals to, see, in the place of V substitute the value I1 R1. So I1 R1 into R1 plus R2 by R1 plus R1 R2. So that is equals to I1 R1 plus R2 by R1 R2. So therefore I1 is equals to, what we can write down? Total current I into R2 by R1 plus R2. So similarly we can write down the value of current of I2 as I2 is equals to V2. V means I2 R2, R1 plus R2 by R1 R2. So that is equals to I2 is equals to I2 into R1 plus R2 by R1. So finally we can write down as I2 is equals to I into R1 by R1 plus R2. So we can easily remember the current division rule formula as, so I1 is equals to, if you want to find out the value of the current which is flowing through the resistor R1, the total current I into opposite value of resistance by total value of resistance. So I1 means what is opposite value? I2. So I is equal I2 which is flowing across R2. So I into R2 by R1 plus R2. If we want to find out the current for I2, total current I into I2 opposite R1 by R1 plus R2. So what is the difference in between this voltage division rule and current division rule? According to formula was, see, there we had taken V1 is equals to total voltage. These are all with respect to voltages in voltage division rule. So that's why V1 is equals to V into total value of divided by total value of resistance. Across what value we are going to find out? V1 means R1. So R1 by R1 plus R2. But in the current division rule, I1 is equals to total value of current into opposite value of resistance by total value of resistance. That is the difference in between the voltage division rule and current division rule. Voltage division rule completely deals with voltages, current division rule completely deals with current. But while coming across the resistances, in voltage division rule, we will write the same value of resistance. But here in the current division rule, we will write the opposite value of resistance. So that is the difference in between the voltage division rule and current division rule. Now let us see small basic problems, then we will get a clear idea about the voltage division and current division rules. See here, find the currents I1 and I2 in the parallel circuit as shown in the figure. So this is the figure they had given. The total current they had given us 20 amperes. So they asked us to find out the currents of I1 and I2. So I1 is equals to total value of current I into I1 means opposite R2 by R1 plus R2. What is the value of R2 here? 10. So 10 total current means directly they had given the current source. So I had taken 20 into R2 means 10 divided by 5 plus 10 total value of resistance. So I1 is equals to 13.33 amps. Next, the current flowing through the resistor R2. So now I am going to find out the resistance for R2. So I2 is equals to total value of current I into opposite value of this means R1. So R1 by R1 plus R2. So 20 into R1 means 5 divided by 5 plus 10. So I2 is equals to 6.67 amperes. So this is a application of current division rule, or this is a problem related to current division rule. Like this, we are going to find out the values of I1 and I2 with the help of the current division rules. Now let us see the problem on the voltage division rule. So here they had given voltage value as 12 volts. Here resistance value 6 ohm and 10 ohm. So according to the voltage division rule, so V1 is equals to total value of voltage. What is the total value of voltage they had given? 12 into R1 by R1 plus R2. Because across which resistor the voltage drop is present, we will consider that resistor. So, V into R1 by R1 plus R2. 12 into 6 by 12, 6 plus 10, 4.5 volts. Voltage across the resistor R2 is V2 is equals to V into R2 by R1 plus R2. So, here we got 7.5 volts. So, these are the basic problems related to current division and voltage division rules. Thank you.